Have you wondered what circular economy is about? Today we will talk about the building sector and the circular economy. To do so, we need to define the old paradigm first and how this old system is a system in crisis. It does not work as we have only this single planet. We face so many challenges these days that we don't even know where to start with. This system relies on externalities. The public pays for the gain of a few. Wealth is distributed in a way that the top 1% owns more than the bottom 99% of all people in the world. The richest 1% from 2016 onwards even gained more than the rest. Single richest 100 persons could end the world poverty 4 times over. You can see in 2008 that this income gap returned its way, and from opening up, which is actually in this case a good thing, is it turned back and the top 1% gained track. So there might be some coincidence to that. Inequality comes with its costs. From educational performance to violence to physical health, mental health, and obesity, the more unequal a country is, the higher you will find the social pain. Social mobility means that you can start as a dishwasher and literally become a millionaire, is something that is also prohibited in more unequal countries. But for all of these, one single thing is there to blame. It is more. It is the quantity that is there. That is the real root of all this bad. As long as we stick to this goal and not think about having maybe another vision, another driver that makes us move and makes us turn our decisions, anything else is just an outcome of this single goal. So that's where the root is. That's, I think, something very important for you to remember. This is the root of all evil. That sounds a bit blasphemic, but if you dig deeper into that, you will understand what I mean. In this new paradigm, the circular economy, which is a solution for the society in a whole, but as said, is not the basic driver. Circular economy consists of basically 2 different cycles. We have a consumption cycle and a service cycle. Everything that is reduced during its consumption needs to be biologically degradable and needs to end up as a nutrient in a biological cycle. Everything that is not consumed during its use needs to become a service product and needs to enter the cycle as a technical nutrient. And only then we can really speak of a circular system. To see it in other terms, we can think of it about keeping the value as high as possible. If you have a shampoo, as an example for the biological cycle, and you use it, you don't want really to destroy the value of it. If you use the value after use, not only you got the value to be cleaned, but you also want something else to benefit from. The current system turns it upside down, and now we need to pay for getting rid of this. In another system, it could be a nutrient for plants, for example, for microbes, for something else to grow on. If you think about it, a washing machine. If you have a washing machine, you sell it as its highest price. All the things are put together, and it's there, and it works as a whole. If you then, after its first lifetime, need to extract it and need to cut it in pieces, you actually destroyed the biggest value. But if you reuse the whole washing machine as a whole, you actually recover the value in its highest possible turn. You can, of course, you can repair it in between and so on, but then you can think about it. One step lower is if you take the boards, the panels of the washing machine and use them separately. You still have a certain value attached to the system. If you then dump it somewhere, you have lost the value forever. So it's also, economists will understand the circular economy as easy as it can get. In general, we work with three strategic pathways. Our biggest and most important objectives is the circularity. Only with these eyes, in this thinking, in this system, we can define things as nutrients. Waste equals food. Then we use nature and nature-based solutions for serving a lot of functions for our problems. And something that is very important as well is the participation. If you don't engage the community from as early as possible, you will lose the game quite soon without even entering any finish line. We are an innovation company. We have a non-profit research arm. We are around 30 people so far. We are very growth oriented because we believe that the growth is not something bad if it's something more common, welfare oriented. And we have our certain background expertise. We exist for now around 20 years. For 14 years, we are cradle to cradle partner. This is if you want, the cradle of the circular economy. And we work a lot on nature-based solutions, strategy developments for municipalities, for whole governments. We have done a lot of phytotechnology research. We work on bio-based materials and a so-called circular bioeconomy. And what we do a lot, we have a lot of European projects, for example, on sustainable and circular buildings, and integrate ecosystem services and material cycles into these buildings, which is what I'm going to talk about. That's the timeline. You see, we grew in the last 10 years quite a lot, not massively, but still good enough. You can find here some links to the some relevant projects. If you want, our website is quite detailed. You can have a look anytime. Houseful, PV Adapt, Recoast, Verteco, Green Instruct, they are all building related projects. The biggest vision we strive for is when waste becomes food. The bad thing is, once you talk about waste, you're already in the wrong system. In a circular system, there should not be waste. You should only think in nutrients, nutrient cycles, if it's a material or if it's a biological cycle. It's a nutrient and it should never become waste. So we start with the biological cycle and the plant powers that we have out there. Plants are capable of doing many things. They're the basic drivers of converting sunlight into all our life. If it is food, if it is the air we breathe, even they can even clean water, suck up metals, or produce fine chemicals. They will deliver the next bioeconomy of our society. Trees provide a lot of services to us humans. They don't only provide all the things I said before, the oxygen and the air and water and so on, but they also provide small habitats for other species to thrive. Their root system is a whole ecosystem by itself. They are an innovation generator and a service provider. If we now extrapolate this innovation into something that we work on, buildings, we can see that a building can be like a tree. It can incorporate all these functions a tree has. It can provide the habitats for other species as well. It can provide food, it can provide clean water, and it can actually clean the air. If one building is a tree, a city can become an ecosystem. So seeing this whole picture of circular cities, we can actually see resource flows, water flows, resource exchanges, energy transfer, and we see the whole water energy food nexus suddenly, which also correlates to employment, by the way. Seeing this is something crucial for designing a city, a building, a process. If we look now in more detail into the buildings, we have again these two cycles. On the one hand, we have the biological cycle. As said, we can use wastewater, we can use organic waste, we can use all even exhaust air of the inhabitants of the buildings and make use of these in a nutrient provision step. So for example, we can use the water and the nutrients found in wastewater and convert them again to edible food products for urban farming. That's all the safe process. We can use the converted sun energy, which is nothing else. If we eat the plants, if we eat animals, whatever it is only converted sun energy in one way or the other. It's the plants that use the sun energy to produce biomass. It's us eating this sun energy. We thrive from this energy, use the nutrients partially, and extort some another part of it. This part can be then converted once more to biogas, for example, energy provision, and or food. We can even collect the rainwater. On the other side is the technical cycle of a building. You can see the smaller the cycle, the less energy input we need. So if you maintain a building, it's something very easy and you recover the value at its best. If you, after the lifetime of a building, reuse a window, for example, you still recover a good amount of the value. If you need a refurbishment, for example, something is broken and it needs to go back, you go one step more back in the whole ladder, but you still recover a certain value. And then you can think of the last, which is the most common thing, but the least favorable in the circular economy, is the recycling, is the crushing into pieces, glass to glass, metal to metal, concrete to concrete in its best way, and then we can again rebuild the materials. We don't need to go back to the rocks and really harvest them, mine them, but we can do this urban mining and recover them and reuse them. And then there's of course the exchange with recycling materials and recycling and reuse materials. I will get to that also later. Solar thermal photovoltaics, capturing sunlight, is also a must in a building, either passively through heat absorption in winter gardens, for example, or more actively with solar thermal photovoltaics. Added value in buildings. How can we add these organic biological cycles into buildings? I give you some examples now. There is, for example, a green wall, the so-called vertical ecosystem. In these walls, we can just like enter solid-free wastewater. It runs through this ecosystem, and at the end, we take out clean water which can be reused in the same building. There are some test results we have done for a big EU project that has already finished so many years ago. You can see these numbers that are reduced to, which are like so-called pollutants, which are then reduced. You can see the input water and the output water in these two classes. They are all fine to be reused. In this way, we can actually convert the nutrients that enter the system with one way or the other. Might it be pee, might it be shampoos, might it be soaps. We convert them in microbial processes inside the root zone of the plants and convert them in the end to plant biomass. This plant biomass can again be used for whatever you want. You can use it for composting, you can use it for fresh air, you can use it for food. There are some more examples, some installations we have done, like a wooden one on the facade panels. Then there are two air treatment units on windows or inside, where we really actively guide the air through the system and use what we call in the one system pollutants, the volatile compounds. We take them up and use them as nutrients in the system. Plants are happy about it, and actually they feed from these so-called pollutants. By the way, these green facades are all filled with chipped bricks and are derived from more than 80% of construction and demolition waste. That's a schematic drawing from how these green walls are connected to a building, and then water can be reused. You have a bit of some more installations with a water tank, with a secondary water tank potentially, but it pays off after a few years. We have driven this idea farther and farther and have now developed something in a quite big context, where we have a good and nice demo sites where we reuse all the effluents of a building, on the material side, on the waste side, on the water side, the energy, and then holistic perspective, including stakeholders, including inhabitants, neighbors, and so on, defining actually business opportunities. In this system, you can see that the wastewater is being separated into liquids and solids. The solids enter the biogas unit together with the organic waste of the same building. The biogas that is produced is being used for cooking directly without further treatment, only some sulfur reduction. And the solid residues from the biogas are used for composting and production of urban farming. The liquids, on the other side, the solid-free wastewater, is turned into these green walls of ours, as I said, and afterwards used for urban farming. In this setup, we can again make use of the sun energy and turn them to food. An aquaponic cycle, as you can see here on the right side, is the exact same thing. The only intermediate is a fish and not a human. Fish poo is used for plant growth. This is well accepted and is being done now in many thousands of installations already worldwide. Of course, you can integrate different like residue streams to produce insects and then feed them to the fish and so on. But anyways, these are you can optimize the certain cycles without other further input. You can even achieve self-sufficiency at some point, but the good thing is you can close cycles at the place where the resource streams occur, and you don't have to transport them hundreds of kilometers. These are our 2 demo sites in Austria. I mean, we have one more, which we will in Austria, which we will not do so many details installations, and we have 2 more installations in Spain of more or less the same size and yeah, same technologies. That's the plan of the building, a schematic flow, how we planned that. So we directly use the wastewater of a building, as said, have the separator installed, the biogas plant installed, and so on, and deliver the biogas directly to the kitchen of the building. This is actually not the newest drawing, but that's like a schematic drawing. Now the things will move a bit more to the outside, and actually we will even do an upgrade of an old oil tank, which is in no further use, and we'll now reuse this same installation as biogas plant. It usually has all the safety measures installed, and just with a small upgrade, it can turn into the next energy source of the building. So that's something for you to read up. If you don't hear it, you will also have the PDFs where only the text is. Usually I prefer not to have too much text, but you can just read up the summary here. Now, seeing the whole picture, this holistic view of how this works in a normal, or what we call broken, food value chain, you can see that our system relies on chemical fertilizers, a lot of transport, very centralized production, going to supermarkets, become your food, and there's always transport in between, being a discarding and then being seen as a pollution, and then even being again discarded. So this system cannot work. In my understanding, it's like ridiculous how you can even design a system like that. But anyway, in an intact system, how we see it is that you have a regenerative system. You grow and distribute where the resources occur. You have a collection system, as you see here on the bottom, and a more decentralized level. You regenerate directly on spot and grow and redistribute. That's a perfect cycle. It's nutrients to nutrients and food to food, however you want to see it. Now, for seeing the nutrient cycles and looking at them, I ask you now to consider how you can integrate these at the Otto Wagner area. So you have the building and you have the area. The building, it might be a bit tricky as it falls under these specific protections, but you have the area still. You need to look into what is possible and how. How can we actually capture water and recover the energy? Where would you put it? Which type of nature-based solutions can you use? And you can see this, I put this water, food, energy, employment nexus that I talked before. How can you create that? Then you can think about the benefits of a solution like that. What are the shared ones and what are the individual ones in the whole system? Who is benefiting? And this directly also leads to the business model creation. Usually you can reach people way better if they have a certain profit. If it's just something that they need to do because environmental demands, nobody will really follow you that easily. You will also face many barriers until this system is established and can be replicated in like many different setups. You can think about these and need to tackle them. You can also then think about what other actors are important in this value chain and how can you convince them to be part of the game. Last but not least is, which I also will talk about a bit later, is how can you actually collect the data, or what can you measure and how can you measure it to really see if the system works and if you do progress in correlation to other systems. The other side, or actually the service orientation, is still part of also the biological cycle, as you see, because we provide services, additional services with a building, other than just living in it. As I said, please take this with you. You can clean air, you can clean water, you can do your energy, you can actually store resources, and you can also recover nutrients in buildings or around buildings. With this approach, you can not only save money, but you can potentially even make money, and you contribute to planet Earth. So it's result oriented, and you decouple the value creation and the negative environmental impact. But now, as I said, we talk about also resources. So a circular economy thinking for the built environment. You have quite a few triggers possibly. You see, there is like a staff cycle. So the thing that lasts the least long is the stuff that you put in a building, the space that you put in that how you arrange your building. You can see there is additional services that with a lifespan of like 7 to 15 years. The skin that you might need some refurbishment after a certain while, and then you have the whole structure that might need either refurbishments from here to there or even a rebuild. But thinking in these cycles is something that is really important for the whole building. You see it on different levels and you see the different lifespans of a building. In this movement called Build Positive, which is the Cradle to Cradle guys, I think took it a bit away from the sites, but you can still find some information about that. I generally like the term Build Positive. Positive is the whole approach of a circular economy. You don't define yourself with negativities, with waste, and you need to reduce waste, making less bad impact, but it's more trying to do more good impact. So with actually every building you build up, you store CO2, you provide the shelter, and you also provide other functions, ecosystem functions, for example, with a building. So you actually create something positive. That's, I think, nice to understand. You can maintain the value of materials. You have concept for an after use, that they become resources again. And you have the circular design already planned during the construction phase, which is a deconstruction and a reuse plan. Very important is cooperation with the supply chain on this behalf. So actually, we need to rethink our construction. It needs to be modular, parts need to be standardized, and we need to have a certain prefabrication that we can employ them quickly and become even cheaper directly on site. There is, of course, an important aspect to that, which is the deconstructability. Once you glue things together, you actually already destroy a certain value, because usually you cannot take them apart again in the exact same value as you put them in. So you really need to rethink how you can make a deconstructible construction. So it's you screw, which you can unscrew afterwards, or you put something that you can easily dismount and take apart. Think about it. If you had like a house that is built for 5 years, you would totally do different ways of using your resources. Think about cement, how actually cement is always maybe somehow problematic. Think about other materials, that when you have like a styrofoam facade and you want to put your mortar on and your plasters and all these things, you put them all together, you glue them all together. What the only thing you can do is you can, in best case, recover a mineral fraction and an organic fraction, and then you can burn the organic fractions in best case, and use the mineral fraction if it's clean enough again in a downcycle it to a cement additive or so. Usually this does not happen. Usually it's still landfilled, right? But think about the way we build our buildings these days, and the way we need to build our buildings the next days. One very important aspect is again on the, especially these days when everything is data driven, is that we learn about how and where everything is positioned. So we need to have a digital twin of our building. That we know where is the metal, we know where is like the steel frames, the windows, how they are connected, where are the wires, where are the pipes, how I can remove them, and all these things. And with mouse click, you know, this building, there is 50 tons of copper stored, 500 tons of cement, and. So that's something very important, and that needs a bit of a change in the planning of the building. Is already quite well perceived, and so many projects have been launched that use really building information modeling as a tool. But it's just for you to know that you can connect these very well also to material passports. A material passport, or a material bank, as they are also called, is something where you can really know the amount of materials, and you can then also think about of the business models that are associated to this material storage. Maybe in future buildings you don't even need to be owner of the materials. In the end, you don't need them. You need the service they provide. You don't need the glass of a window. You need to look through something. You don't need to own the brick of your wall. You just need a wall that protects you from the outside. So if you think about it, all these can actually still be service driven. The same is true, of course, might be an easier example, a car. You don't actually need the materials of a car. You need the function of a car. You need the function of a washing machine. So thinking this further, a whole building becomes certain aspects of different services incorporated and merged together and stored there for the lifetime of the building. What is currently already happening is a so-called material exchange platform. There have been many attempts, and materials are exchanged, like old bricks, like windows, like glasses, and so on. But it's really slow how it's happening. It's not happening systematically, and there is not even a big demand. Even architects, you have heard so many architect speeches, have to rethink how buildings are done in the future. You cannot always take new materials and just get new materials. You need to look where are certain materials like close by, which kind of materials, and then plan the building based on these materials. So that needs a totally different way of interaction with many more stakeholders. I think that a lot will go through digitalization again, but it's something we need to look for, especially if you do big projects. I think it's still very difficult to find all the materials from a secondary market. If you're a small house builder, a private one, there might be chances that you find your 15 bricks that you need, or okay, 50, probably more than that, but you know what I mean. It's easier to find on small scale than on big scale things. But these things change and need to change also in the next years. What is already being done is the so-called urban mining. Urban mining is still perceived mostly on the recycling level. So you crash down an old building, you crash it, you shred it into pieces, smallest pieces possible, and then you can reuse them in new cement layers, the gravel. So you replace the gravel part in the cement with the new crushed parts and pieces. There's like Thomas Rom, who is a front runner in this area, and even the city of Vienna is using these methods quite often. There's even a law in Austria that over a certain size of a building, I think it's 200 tons of building and construction demolition waste, you need to have a deconstruction plan and a reuse plan of your building materials. Recycle building materials ordinance is this name. But this now needs to happen, or will happen actually, on a big level. Europe will push for it with all the new laws and so the new circular economy action plan. If you have not come across that, by the way, look at that. Look at circular economy action plan on the Commission, and you will be astonished of what the Commission actually demands for the next 30 years, how our society needs to change. You will see that all this thinking will be part of our everyday's life in a few years to come. So what we do now so far, if you start a project, you do the end of life assessment from the beginning. That's called circular design. But if you're now in a project where you have a certain deconstruction site, you do the end of life assessment um, already in the end, or you think about during the lifetime, or whenever you found the time. So many building out there, so many things have to be considered. Could you now dismantle the actual buildings and recover the highest value possible? Then you need to tie it into the logistics part. Where do the parts go? Where can they be stored? Storing is money, right? You need the space. Somebody needs to pay for that. And then with every, like, if you need to dismantle, imagine you need hands to dismantle. You need then hands to put it somewhere, and maybe more hands to put it again somewhere else. And so if you have a storage in between, it's costs, and it's more cost efficient if you take it from one deconstruction site directly to another construction site. That needs to be planned well. Then the question is how you can recycle. So is there a shredder that you need for at your size? How can you reuse? No architect so far will allow your building to be done with recovered steel frames. The bars, the windows, they cannot calculate these. You know, there might be other openings, and then they said, I want a passive building. How can I ensure that these windows fulfill these functions? So this is very common, even of very progressed architects. These understanding is very far from current systems. You need to assess how you can actually separate the certain materials. Imagine you crash down a house and you have polystyrene, polyurethane, copper, and all these different, of course, steel, cement, and brick, and you name it. And you have a big pile of all these things, and how can you actually separate them on site? If you take them as they are and you put them somewhere, you need to carry many things to a certain place where they are again separated and then put them somewhere else. So maybe a decentralized separation unit will work for your case. We also need to think about the resource stream. How much of it is it, and yeah, and how clean it can be. and then find the building to be reused, or let it enter this exchange market that I said before. Now, we do all these assessments and these tests, how we can reuse them and so on. We need also to find out how we can measure circularity. They are so-called, these indicators, often key performance indicators. We currently write some publications on that and have a full master thesis running on that, where we only check certain circularity applicators and see how they can really be applicable in real life. So we will talk to the Strabag or so, like a big building company, and try to involve them in a circularity indicator during a construction, something so still far from normal building ideas and people that are involved, but it's an important aspect. Maybe just a small detour. In my understanding, the whole economy is built on something that is calculatable. It's numbers. It's the economists that came up with theories and numbers that they want to achieve. And then they found a number that you can call it gross domestic product, or you can call it balance sheet, or however. Uh, it's something that they want to grow. So if you now give them other numbers, these let's say it's a game. The whole economy is a game, and if they then play with other numbers and grow these numbers, and these are then quality numbers, then maybe you attract at least these people that have the game side as main driver. This was just a small detour for understanding that circularity indicators is something that is very necessary to see. Also, you need to see how circular a building is, a certain solution is. If you put these wooden joints together with a metal screw, is it more circular than a brick with a you need to think of many things in this whole setup. There are big lists out there. There are these certifications. If this is a LEED, a BREEAMS, a Levels, DGNB, ÖGNI, whatever. You will find all certain indicators for certain aspects. Soon we will publish a very detailed paper just on that, where we have collected, I think, all possible indicators that somebody can pick up. In one project, we try to push on these, that you can find the best suitable indicators for your project. And then, of course, you can also have the guidelines on how to measure these. For a building, it's important that you set clear objectives and that you set clear ways of measuring the progress to achieve these objectives. Considering always the whole life cycle of a building, right? Do not forget about that. It's not only about the construction, it's about the whole life cycle of a building. That's also something important, to always see the whole building life cycle rather than just the capital expenditures that are needed to build it up, to set it up. There was a project quite some years ago, which was really a flagship project, as still, even these days, the methods we used are not very common. We used circularity in all these sub-projects and try to achieve a zero waste building. Yeah, it's one project consisting of many. You can see the left building here this was the already built one. The right is the new building that we build within this project, and the central one is the one that should be built once the you can see, yeah, the round one that should be built once the new economic allow it for it to be built. In this construction on the right, you can see it's full photovoltaic. There's actually a production process running in it. There's offset and digital printing machines. That's a company. And we integrated the printing process into the building life cycle, and we used their old plates as facade panels, for example. They're old printing plates, which they usually need to discard. So that's an R-rated facade system with these printing plates. Of course, it's full self-sufficient, and the whole we capture the water and all these things. Yeah, I do another course, and we will for circular cities and circular buildings, and we will visit this building in this other course. And maybe you, Donau University of Krems next year, if you want to join. Yeah, you can also Google it, Google Googler, and you will find it. And there are, I think, every first Thursday in a month or so, there are visits to this building. It's definitely worthwhile seeing. They also have organic kitchen, only very nice food. The food is produced directly in the house, and Googler, the 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 boss, is very inspiring person. Now, talking about also the photovoltaics, how to integrate them in a certain building. We have done another project where we did the building integrated photovoltaics, and we combined them with a heat mat, so actually recovering the heat energy. It's always low temperature, so low temperature heat, but the panels will always run on 25 degrees, so that they can run at its highest efficiency, and we always have this waste heat. It's a very easy heat mat, and yeah, bring costs down. Alternatively, we can, instead of having just the structure insulating facade panel, we can also add a green wall, and a green wall plus a semi-transparent photovoltaic system on top. And the green wall of ours, again, is of course cleans water and the like. So we have considered quite a few of the smart envelope systems and circularity aspects, multifunctional things, and we have done a whole supply chain analysis of how we can actually then reduce the costs, and how we can do the logistics of forth and back on beginning of the building and after the lifespan of a building, and so on. And yeah, we made like a year plan. Of course, currently is still not possible to make the whole supply chain circular, but we have also looked what is possible, what will be possible in the next years, and how we can actually then recover the materials and reuse them again. Now, this thinking of a full life cycle of a building is of course very well captured if you consider a product. A product can become a service. As said, the washing machine before. Usually, when producers sell you the washing machine as a whole, they try to make you rebuy the washing machine after a certain set of years. That's the business. They sell washing machines. But on the other hand, if they sold you a service of washing and they still own the washing machine, they try to make the quality as good as possible, that it shall hold one lifetime and will not break. The same is true for any other thing you can imagine. You can also lease jeans these days and get them back, so they can really reuse the jean or the fibers. There are tools libraries. And of course, a very famous example is the light as a service. A light bulb is something you don't really want to own, but we own it all the time. We buy light bulbs and then we need to discard them. Now they have increased the lifetime with the LEDs, but still, even these have to break at some point, or at least get worse, that you need to rebuy them. Otherwise, how can the company survive? So, in the lighting as service concept, which has been implemented in many areas, for example, one famous example is the Schiphol Airport. Philips owns all the lights, and Amsterdam just buys the service of a light. And this setup, again, Philips is not interested in exchanging all the bulbs every once in a while. They will produce the highest quality possible and will install them and maintain them, and will look on very close loop systems. Some more examples are there to come. There is one company called Sekisui Chemical. They actually do prefabricated buildings and have a take back scheme after the use. And they can really reuse 85% of the house mass. They will own the building, and you can just buy the service of a building. There are some other solutions out there. Toma Wood 100, for example. It's like cradle to cradle proven. It's a very good material. It's not a service in this sense, but it's at least the material is circular. All the wood is very sustainable. There are no glued connection inside, and it's like 100% wood without you don't even need screws, and there are no preservatives, and it's very durable. And yeah. Or there is the wood insulation that is with an additive impregnated with a whey and soda, baking soda, and in this way it becomes fireproof. The material remains recyclable and can be used as blown-in insulation. Or Akoya wood, which is acetylated wood. It's very resistant. It's not used with any colors, and it can endure many years even inside water. It's just like a small baking process that the wood undergoes before it's being sent out. Target floors. This is floor as a service. You can get them back. High quality materials, wood or linoleum, wall or floor cover. Interface carpets are quite well known, I suppose. They are DC free. They are used for professional like sales usually. They're very modular, and you can always give them back and take new ones. And yeah, you lease them only. Another story is what is part of a circular economy besides these service models and the directly buy of new stuff in the end is upcycling. You can basically turn anything into anything else somehow with using like old shoes, old bottles, skateboards, and you can see some examples. You can be as creative as possible to really make use of all your old stuff. Even children love to play and love just to form something new from something old. It's a very fun game. You can try it out if you have children by chance, or um, aunts or so that have smaller children. You can also use building materials for upcycling. You can use old wood from a construction site and make it new. Fire hoses are very good and very strong building material as well. You can put couches, you can build fun games, ladders, and so on. They are built to last, but also they need to replace the fire hoses every 5 years or so. So if you have a fire brigade next in your city, or you know about them, you can ask them. They usually give these away for free. We found I don't know how many kilograms of fire hoses just for free. We just got there and got them and have now access. We will now do urban farming things and many more stuff with these fire hoses. Another thing we did actually inside Otto Wagner area is an old furniture upcycling. We had so much old furniture that was useless, and with the help of Caritas and many refugees, we were able to turn them into new pieces. And now they are all super stylish. We even sold some of them for good money, and it's worthwhile to look into old furniture upcycling. It's an easy thing. You usually just need somebody who has some hands-on skills, and you can do it in a very nice and co-creative way. Another approach for decentralized value creation is plastics recycling and reuse. So you can really take the caps from your plastic bottles, which is a polypropylene, by the way. You can shred them, you can make a new filament, and you can use them directly for 3D prints. The bad 3D prints can be go through the same way, or the bad 3D prints of somebody else in your. You just need to look at the if it's the same material. Usually, you can 3D printing is very PLA based, so you can have a PLA cycle. You can have a PET cycle with your PET bottles, or as said with the caps, a PP cycle. You can even use these for construction. 3D printing and automation in construction is used more and more for bigger and bigger projects. They reduce costs immensely, materials as well, and you can have all the properties of a nice building, and you have more like round shapes as well. You can have robots do the job for a tenth of the price in the end. Of course, the materials and the recovery of the materials is another story, but it's usually very often, for example, hempcrete is used. Or not very often, that's like exaggeration, but it's usually cement mixtures, but you can use also hempcrete or bio-based fibers together with cement. Now, for looking into the Otto Wagner area, the question to you is how can you really maintain or increase the value in and with the building? So how can you make this restoration and reconstructable? Imagine it's not only that you deconstruct it, but also reconstruct it afterwards. What are the associated business models that suit the needs? Think again about the barriers. You know that this restoration site is very special, and there are barriers well known. Then think about who else plays a role in the supply chain and the value chain. And then again, as before, think about how can you collect the data to measure your progress. What is it that you can measure, and how can you measure it? So, summing it up, this is a nice graph which you can look at in your PDF presentation, summing up what a property and what a user is doing in a building, how this actually works. This is an Australian graphic, so even in Australia there seems to be movement around the topic. And I liked it as it really shows the different processes and how far somebody has to go back in the chain to make a reuse or any kind of cycle possible. You see, the farther the cycle goes, the more energy you need to put in and the more value you lose. That's something important for the circular economy. But something even more important is the aim that we strive for. So instead of having more and quantity, it's now turning into the quality of life. You can also make money by building something good. To achieve this, we need a social transformation. 5 stages for social transformation: forming, storming, norming, performing, and then transformation. Think about it. That's something you can dive as deep as you want, and you need social innovations to have a social transformation.